Alright, so this is the graph from the question. So we have O, R, and Q. Distance between O, R, and Q is 200 miles. Distance between O and R is 80 miles. The ship is over here, somewhere over here. We have to find the distance and bearing from O to the ship. So these are the points where O, R, and Q lay at. The coordinates: O is located at 0, 0 at the origin. R is located at 080. Q is located at 200 comma 0. First question, you have to find two hyperbolas, which will help you find the intersection between the two, and which will come and help in finding the distance and the bearing. So to begin, we'll start with O to R. For the hyperbolas, keep in mind that O will be the focus point. The focal point for both hyperbolas, O will be the foci point. To begin, we'll start finding the center. O and R, which lays at 040, which is half the distance of 80 miles. 80 divided by 2 is 40. That's where the center lays at. What this help you find is that the value of C. Since I said the foci point is at O, you know that from previous knowledge, you know the distance between the center and the foci point is C. So we'll start with the first hyperbola with points O and R. So first we want to find what the value of A is. We'll start off with 2A. From the question, it gives you the unit seconds that will distance between O and R. Distance is 323.27 units second. That's given in the problem. Over 1. In order to solve for A, you also have to know what unit seconds equals to feet. So 1 unit second equals 980 feet. So in order to cancel out unit seconds from the top, you have to place the unit seconds at the bottom. And then 900 feet goes on top. What this will do will be 323.27 divided by 1 times 980. However, you also have to, the other factor, which is the miles. You have to cancel out feet. And in 1 mile, there's 5,280 feet. In 1 mile. So in all, what this translates is to 323.27 unit seconds divided by 1 unit second times multiplied by 980 feet divided by 5,280 feet times 1 mile, which will give you an estimate of 60 miles. However, in order to get the most accurate information, I'd recommend you use to solve this all on your calculator, and then save the full decimal answer to a letter. In this calculator, I've saved then you'll divide this by 2 to find A, and in the calculator I have the value of A saved as 30 feet. These are other letters you'll figure out right now. So A equals 30. That's the complete decimal. It's kind of hard to write all the decimal letters, so if you could save it, it helps you figure out the later on. So just for sake of writing this down right now, I'll just put A equals 30 miles. However, I'd recommend you saving it like that. So in order to show you, 323.27 times 980 equals that 300,006 that I'm sorry then divided by 5,280, you get that's the value of 2a 60.0009. Then divided by 2, which is you get the value of a, and then you save that under a, and then you'll figure out what b is right now. But from your previous knowledge, you know what the value of c is. O is the foci, and this is the center point. The distance between the center and the foci point is equal to c. The value of c is 40 miles. There's no decimals. It's just 40 miles. In order to find b, you use the Pythagorean relation c squared equals a squared plus b squared. You plug in the points. This is where the value of a comes in helpful, because all you have to do is plug in a squared, and then you could plug in 40 squared, and then this should be easy to solve. Just to for time's sake, you'll get b equals something around 26.457, but once again that's rounded, so I'd recommend you saving that point just similar to a. So right here, so 40 squared minus a squared, which is 699.974. Then under the radical, and that's the value of b. So save that. What this also helps you is find the first hyperbola. For the first hyperbola, the hyperbola will be from north to south. So it will be y equals 40, going back to the center. This is k and this is h. This is why finding the center was very vital to finding it. So you'll put a squared, which is 30 miles, but when you graph it, you want to put a squared as you've saved it, and then a x squared over b squared. What this will do is basically put out the whole decimal and give you the most accurate point. This is probably the most accurate hyperbola for this question. Then you have to find the second hyperbola. This time it's with O to Q. Right. Similar steps. So you'll go back, you find the center. This time it's going to be 100, 0. It's a center between those two. Once again, I repeat, O is the foci. So you want to find 2A as well for this question. 2A equals, well, and in this question, and in this situation, the question gives you that distance is 646.53 unit seconds. Put that over 1. Once again, similar to same as this. Actually, this other half is same as previous. So 980 feet. Over 1 mile. It's the same as the previous one with the first hyperbola, just the difference in the seconds as the question gave you. This will round out to 120 miles, and then once you divide that by 2, you'll find what the value of A is. You'll get approximately 60 miles, but once again, it's an estimate. I recommend you save the value as, let me show. And in this case, I saved it under C. So C equals A. This is the second for the second hyperbola. C and D is for second hyperbola. So this is what the value of A for second hyperbola is. 59.9999. Um, so, but rounds out to A squared to 60 miles. But once again, just to save space. But when you're plugging this in, you want to store in the value. Then you want to find the value of C squared of C. Well, C you already know. I'm sorry. Um, the foci and the center, the distance between the center and the foci, it equals C. So in this case, C will equal 100 miles. You want to find what B equals. C squared equals A squared plus B squared. This is where storing the values comes to hand. So you'll have, in this case, 100 miles squared equals A squared plus B squared. But in my case, I saved A squared under the letter C. So after square rooting it, and just to save space, you'll get B equals an estimate of 80 miles. But once again, it's a large decimal. To be precise, this is what the decimal looks like. But if you store the value with control VAR, you'll get around that number. For this hyperbola, the hyperbola will be facing north to south. This one face east to west. So it will be x minus 100 over a squared minus y squared over b squared. Alright, so now that you know what the two equations for a hyperbola is, you have to graph both of them and find the intersection. So now, this is where I meant saving the value will help you. Here we go to y minus 40 squared over a squared minus x squared over b squared. You can see the bolded A and B because those two letters have a value stored in them. It gives you a most accurate point. And then for the second equation, this is A and this is B, but since A and B were already used, I use C and D. So just A squared and B squared. So x minus 100 squared, then minus y squared. So A squared and B squared. No confusion. Alright, so the point that you'll find is that point. That's where the both hyperbolas intersect. So basically this is x value and this is y value. So I'll go for the distance first. The distance equation formula equals square root of y squared over x squared plus x squared. All you have to do is plug in this value for here for x and the y value for here. You'll find the distance to be just to be that. Um, that's the whole decimal. You could round after, since we've gone to the end of the problem, you could just round this to 3 decimal places. So 1371.368. And it should be in miles. That's one answer. That's one part of the answer. Now bearing. Bearing is uses this equation. 90 degrees minus 10 minus 1 over yx. In this particular case, this is what the bearing equation will look like. The reason why the 90 degrees is because once you plot both hyperbolas, you find that the intersection happens here in the 90 degrees. This is where intersection will happen. That's where you get the 90 degrees. And then after you plug in the y and x value, which is here, just as once again save time, 90 minus 10 and now the important thing about this situation is you want to switch your calculator from radians to degrees. So you go to document settings, then you go to radian. You want to make sure you set that to degree. Enter. Make sure that says degree. So 90, then you get minus 10 minus 1. You get an estimate of that. You could round it, which will be 40.291. To write bearing, since this is from north to east, you'll have north. This is the north, east, south, west. In this case, it's from north to east, so north 40 291 degrees east, and that's the value of bearing. So there you go.